Right, let's go. Right, so today we're focusing on logs. I showed you initially the graph of the exponent, right? So head up logs, focusing on logs and log today, right? Yeah, that's what you want. We still have more. Right, so during holiday, did about 5 or 6 classes, right? Two, because a little bit longer, because 2 or 3 hours. What? 2 hours or 3 hours. I'll tell it. I'm gonna sign on you today. Later on, so like in person. Yeah. In person and well, for online, you have 2 hours. 2 hours. While you're away, you can just do some Wi-Fi for 2 hours. Right. Anyway, I'll send the timetable, right? Right. So last day we did this, right? We did functions that look like that, right? Y is equals to the x, right? We did all those exponential functions. Yeah, we did that. Huh? Yeah, I give you're logging on. MP did all these. So I'd never given this graphic before. Right? So I know I give all of that graph. Right? I know I give all of this graph. All right. Anyway. Right? We did some indices, right? So this is technically the graph for indices. It's called the exponential graph. It looks like this. All right. Today we are going to focus on the reflection of this graph in the line y is equal to x. That reflection is logs. It's the log graph, right? Which is y is equal to log to the base a of x. Right? So what that says here, that says that log to the base a of x is the inverse of y is equal to a to the power of x. So what this implies is that there's a way for us to go from this to this form, right? So we should be able to go online, you're here, right? And seeing, right? We should be able to go from the exponential form to the log form. Online, you're here. Bradley, Kila, all right, nice. So good. How do we go from exponential form to log form? All this is maths, right? If I give you something like this, if I give you a to the x is equal to y, all I have to do is this, right? Watch this here. If I want to convert it to logs, this will be log. This a becomes the base. This y becomes the value of finding log of, and x becomes the answer. That's okay? So to go from exponent form to log form, that's what you do, right? This is the base, this is the value of finding log of, and this here is the answer. Right? We could watch a real small example here, Ariane. Right? 3 squared is what? 3 squared is 9, right? So if I want to convert that to log, it will become log of 9 to the base 3, right? Remember the a coming down, x going across, the y coming across, right? So it will be log to the base 3 of 9 is equal to 2. Right? If you remember your log rules from form 5, you should be able to move from here to here. That's okay? Right? What's this called this line here? What is called this line? Y. What is called this line here, the y-axis? In terms of this function here. What? What do you call that then? Right? Note that for y is equal to log a to the x, there are two things I want you to note. Number one, I want you to note that the y, I want you to note that the y-axis is an crap. Spell that right? Go. Go. So it's somewhere around here, right? But anyway, this y-axis here is what we call the asymptote. Right? The curve will come close to that line, but never touch it. Right? So what does that imply? That implies, right? This implies what? If it comes close to the y-axis but never touches it. Well, what does that apply? What does that imply here? Huh? It will never be zero, right? So therefore, log to the ax cannot be equal to zero. That's okay? That's what asymptote means, right? So it will come close to the line but never touches it. Right? And there's one more thing. Can you find log of a negative value? Yeah? Because look at the graph. The graph is only for positive x values. Okay? So y is equal to log a to the x only exists for x is more than 0. Okay? So it's important that once you see that x value negative, you know, no solution, right? All right, so there's two little rules I wanted to remember about this log graph, right? So if ever you have to draw it, don't ever let it touch the y-axis. You can come close and don't let it cross the y-axis because it don't exist for those values, right, Darion? Painting a little rest on Darion. Right? When it go back on it. Right, let's check out some rules. Let's see if you remember the rules, right? I want to start with this rule here. Not really a rule. I'm going to call it a rule. If I call it a rule. Right? Log to the base 10, right? Sometimes you don't see log to the base 10. What you'll see? LG. Okay? Now, suppose you see log to the base E. Log to the base E, this is called natural logs or natural logs, right? I find by the next name for it, right? But this is called natural logs. So instead of me writing log E, they abbreviated by writing log. That's okay? So log E is the same as log. I know I drew that graph for you. I'm sure the log I'm not. Yes, yes, yeah. No, I know I saw that. I feel so, you know. All right. So, all right. So just some things I wanted to note, right? So let's officially go to the rules then. Anyway, I'll leave it under the rule. Right? Let's start with log A. What's that? 1. If you don't remember the rules, you can go back to the indices and convert them, right? A to the power 1 is 1. Right? What about next one? What about log to the base A of 1? That's always 0. Right? What she's doing in a case like this, log to the base A of m to the power n. Right? We can call it's called power rule, right? We can take the n, put it in front. Online, are you okay? I'll get you online, Isaac. Isaiah, I mean. Amber, are you okay? Isaiah. Right, next rule, number 5. Suppose I gave you log to the base a of m and I have an addition sign in the middle. Right? Well, what you'll do to simplify log to the base a of m plus log to the base a of n. What you do? Right? Multiply, right? Plus implies that we simplify without multiplication. That's okay? What you will recognize, right? What you will recognize, you'll recognize that they must be the same base, right? What about this here? What about this rule here? What this is here? I wanted to catch you. That's why I put 5 here. There's not a rule, right? This is not a rule, right? Multiplying same base is not the same as this. That's okay? So be careful. This is not a rule. That's all right. It's twice, right? Huh? Oh, sure. All right. 7. Right? Log to the base a of m minus log to the base a of n. Minus means we go into paper. Okay? So please don't make up any rules, right? All right, so these are the log rules that we need to remember. But there's something I want to point out, right? Suppose I gave you log e. What is this?
1.
Why is 1? Right, because ln is the same as
1.
ln is the same as log to the base e.
Yeah.
So log to the base e of e is 1.
Yes.
Right? Here, ln 2x plus ln x is what? What you do here? Right? Same rules as this. Whatever you can do for log, you can do for ln. Why? Because and ln is just log to a different base, the base e. Right? So what that means that the same rule that we use here, we could use here. Yeah? So therefore, ln 2x plus ln x will be ln 2x multiplied by x, which is 2x squared. You okay with that? Everybody okay with us? So you're multiplying, right? How can I simplify this here? What I have to do? Right? Because of the log rules, right? I can just take the 3 and bring it in front. Everybody okay with us? Yeah? Yeah. About question. Faith. Can I take this 2 and bring it in front here? Can I take this 2 and bring it in front here? Yeah? Yeah? No. Right? Because this 2 is only to the power of x. Right? If I put a 2 in front here, it's going to be multiplied by this whole thing. Right? So if it was like that, then I can bring it 2 in front. That's okay? So that's the only time that I can use power rule. That's okay with that? And one more rule that's new, change the base formula. Right? Where's that? Yeah, if it have value here, then it will be the whole thing. That's what I said. If it has something. Follow
So
two.
the bigger, right? You find your result.
Because think about what this is, right? This is ln 2 plus ln x squared. If I put it 2 in front here and put a root here, I change the whole thing. Clear enough? Any questions online? Okay, so these are your certain rules here. One more rule I want to give you. Oh, by the way. Anyways, you might see that as it. Everybody have this, right? Right, one more rule I want to show you is called a change of base rule, right? All right, suppose I want to go, let's say I want to change the base from A to B. So if I give you log to the base A of M, right? If I wanted to change log to the base A to the base B, Darian, you remember what to do? Yeah, tell me. Right? So what you do? The new base is log to the base B. Right? That's the new base. Okay with that? That's the new base. What goes here is the old number. What goes here is the old base. Okay? So log to the base. So A goes here, M goes here. That's all. So for example, if I ask you to convert log to the base 3 of 5 and I wanted to convert to the base 4, all you're going to do is this. Right? You're converting base 3 to base 4. You write log to the base 4 here, log to the base 4 here, and the 5 comes here, and the old base comes. The old base comes here. Are you okay with that? Right? Victoria, since you look like you do like that, we have to prove it. Right? We had to prove that, Victoria. Go ahead, have fun, prove it. Right, so I'm going to show you how to prove that, right? How to prove the change of base formula. Okay, now. When you move from log of base to log of five density, the new spaces, the log of three density. Just do my favor to convince yourself now. Put this in your calculator. Well, Casio, work it out. Put this in your calculator. Tell me what you got. Should get the same value, right? Shaft calculator, Casio. Log to the base 3 of 5. Write down the answer. Log to the base 4 of 5 divided by log 4/3. Work it out and make sure you get the same answer. Ready? I want to show you the proof for this, right? I want to show you where this came out from. Right, please remember we can only use these rules if we have the same piece, right? So the questions you are going to see will not be in the same piece, right? So you gotta remember to change the base and then wrote it down. Copy them. Let's try one. Sorry, let me show you that proof there. Have one. That's not. No, I don't prove it. I can't prove it. It's a little tricky to prove. It have two initial lines by any help with. After that it is. Right? I'm gonna show you that now. Are again the same values? Yeah? Alright. Ready? So watch this here. Right? So if we have y is equal to log to the base a of m, right? And I want to convert this to the base b. Right? Everybody ready? Right. So I want to convert y is equal to log to the base of m to the base b. Can I convert this to exponential form? So if I convert this to exponential form, what would I get? What would I get here? A to the power of y is equal to m. That's okay? So now, here's what we know. We know that m is equal to a to the power of y. Now, if I take logs on both sides, let me be specific, right? Let's say I take log to the base b on both sides. What will happen? I will get log to the base b of m is equal to log to the base b of a all to the power of y. Okay with that? But what will I do with this y? I can bring it in front, right? So I'll get log to the base b of m is equal to y by log to the base b of a. Correct? I can bring this here. So I'll get log to the base m of b is equal to log of a, sorry, to the base b is y. Okay, I'll bring this here. That's okay? What was y initially? Y was initially this. So y was this here. So log to the base a of m is equal to this. Okay with that? Because I don't like this and I want to put it in the base. So I'm gonna write it back and I'm gonna change the base. Right? So that'll be true for it, right? Copy it down. Let's see if we can tackle some questions now. Right, so remember you change up the formula. I just squeeze it in here and I'm leaving this list here, right? Now we call this number 2. Oh yeah. Okay, decrease it times. Let's start. So from next week. Hello? Okay.
You want me to tell you what's happening now? You want me to start on your piece? I have that to move down very last regularly.
Yeah.
Yeah.
Yes, we got it. Okay. Well, I have it. I'm going to this way. I got 3 on one. Yeah. All right. Where are we? Where are we? Right. So let's start with questions. So as I said, the only way we can use these rules here, Kalina, is that everything must be in the same piece, right? Everything must be in the same piece. Right? I'm gonna give you the one just to warm up with. I'm giving you a simple one just to warm up with, right?
See,
Right? What are we doing here? Yeah? Same base addition sign. So we're going on what? Same base addition sign, we're going to multiply. And then when you have log on one side, constant on the next side, it's up to you. You could convert to exponential 4, or you could write 1 as a log. It's up to you. Any technique you want. All right. Try it if you can't remember. I'll do it just now. Try it if you can't remember. I shall do it. Give me 2 way, but you'll be smiling. That's not. Let's see. I like to just start with that. That's the reason why I like to. No, really, we're not getting. You're ready. But yeah. I came back. Alright, so what is here? Risha, you do one, I just want to help people on that. I want to help you be shared. I have 1 minute, I got it, right? 1 minute. Right, let me just you here, Yash here today. We had no class last week. Still here. Shana here, Bradley was online, Samira, Esther, Pete. Do not hold the right up on the screen. Jacob didn't come. Jacob online.
Minus in because log line of that I agree right and negative negative. Yeah, oh, yeah, okay, yeah. Yeah. Like they after privilege. Yes.
All right, so what we have here. Right, let's try this out fast. This will be log to the base 5. Addition means multiply. Right? Here, I could convert to logs, I could convert to exponential form, or I could write this. 1 in terms of base 5 will be 5, 5. Then I could drop the logs. Right? I don't like that method so much, but I'll just show you, right? The method I like is, since I'm here, I don't want to introduce anything. All I'm gonna do here is convert to exponential form, right? So bring up the 5, carry across the 1, carry this product on this side.
That basically same thing.
Yeah, same thing, right? And you'll end up with, right? The reason I like this one is that if I have 3 here, remember it could be 3 log 5, 5, right? So sometimes people forget to bring the 3 on top there, right? Put back the 3 on top of the 5. Anyway, multiply this out, you get x squared. X squared plus 2x minus 3. So you'll end up with x squared plus 2x minus 8 is 0. Right? And we will end up with what? 4 and 2. So we will get x is minus 4 and x is 2. Yeah? What's the problem with minus 4? Right? Invalid because we can't find log of a negative number, right? Okay. So this here is the form 5 sum. All right? Let's focus on the real thing now, right? Let me see if anybody online messaging any answers. Bradley, Caleb, nice. Amber, do we get the message answers, Amber? You all okay with us? Right? So now I'm going to give you what you might actually see in exam, right? I'm going to give you one where you don't have the same piece. So what you'll do? Change the base, right? Normally you change the higher to the lower, right? As opposed to the lower base to the higher. But it was still working the markup. You're really happy on your channel. Finish? I'm not real quiet all the time. I sound like you real happy, but
I will stop here.
go ahead. Try this one here. Log to the base 4 of x is equal to 1 plus log to the base 2 of 2x. Anybody log to this one here? I'll come and show you it. Are you okay with this one? Alright, go ahead. Have fun there. Have fun there.
What?
Fun. Underline the word fun. If you're not having fun, don't bother with that. Let me see what went on today. Let me see what went on today. Yeah, my old key. Huh? Peace? No, I can't go. I was playing one. He was at my elbow. So bad looking now with all here. Come on.
Yes, sir, believe it.
I see you also. Go ahead, convert to the same base and let's work it out, right? Again, normally you convert the higher base to lower base, right? Okay, come on. You have a fraction and it will like it, multiply two outside that fraction, right? Yeah, oh, that's nearly 40 for you'll do it in half an hour. Yeah. Still have 7, right? Still have past 7, right, Aaron? Somewhere. Right, we have until half. So from next week we'll go to 7, right? Right, so good. So we're using this rule first. Right, bring all the logs together and then use the rule. Up to you.
So,
Yeah,
like, soon. So,
I wish. No, I can't.
class right now.
I was trying to push them back, but they complain.
But you can like, class for something else. Okay.
So, but the way, in the holidays is 2 or 2.5 or something.
So, I'm very disappointed.
In the holidays is 2 hours for sure. Or more. That's true. But I'm feel like I'll get one. Well, you want to come every day? Right, but that doesn't make it.
I don't think it's very true. I'm very good.
They don't get out. Yeah, change it. We're going to the base too. Change the base formula. Yes. Yeah. Whenever we shut the end. Right, so here would be log, no, I'm not doing, I'm just doing the first line. Right, log to the base 2 of x all over log to the base 2 of 4. Okay, please remember you have to simplify this out, right? And I just bring in all the logs together, right? All right, go ahead. Online, when you guys message your answer. Ready?
Yeah.
1 second. I just write in one thing here. Instead of 4, I write in 2 squared. Right, so please remember that 2 squared, which is 4, I can bring it 2 in front here, right? And we know that log 2 is 1. So I have 2 in my denominator. So what to do? I don't want that, right? So I'm going to multiply every term by 2. Okay, 2 will cancel here. I'll get log to the base 2 of x. Multiply 2 by this, I'll get 2 log to the base 2 of 2x.
Yeah, I guess.
Multiply 2 by 1 and I'll get 2. Right? The reason I did that is to avoid having to work with the fraction. But here's the problem, Keshav. When I take this 2 and I bring it here, would it be 2x squared or would it be 2x all squared? Right? So I'll end up with log to the base 2 of x minus log to the base 2 of 2x all squared. Okay? I think you'll make a mistake here, so fix it fast. Right? When you take it 2, you bring it to square this whole thing, right? Now, same base minus, so what we gonna do? Divide, right? Fix it quick. Huh? Yeah. Huh? I can't go to the base 2. You can't go to the base 4 if you want. Alright, so I'll go take it out. What does minus mean? Minus means divide, right? So that would be log to the base 2 of x divided by 2 squared x squared, right? So that's 4x squared. Okay? Equal to 2. Correct? Can I convert this to exponential form one time? So I'll end up with 2 to the power of 2 is equal to this. X over 4x squared. Now I can cross multiply. So I'll get 4 by this is 16x squared. 4 by this is this, 1 by x. So you're going to get 16x squared minus x is 0. When you solve this, you should get x is 0 and x is what? 1 on 16? Yeah? 1 on 16? Before we do that, right? There's something I want to point out. Watch this here. Olha. If you were to cancel the x here, right? You will not get this 0 value. You're going to lose a solution. Okay? But technically, is this a solution? No, because it said x must be more than 0. So your only solution is this.
Wait. If you cancel what?
If it cancel the x here and you get 1 on 4x, right? You would have only gotten this solution. But if in a question you needed this solution, you would have lost it. Yeah. Right? That's now. Any questions here, Olia? I'm going to show you one more time, right? I have a minus here. Yeah. The thought is m over n.
Yeah, I'll try and say it.
Just over this. Right? So just over this and then I convert and I cross multiply. Online, any questions? If you will do over line, tell me which line I'm going to do. Okay. Let's go again. Any questions online?
Let's see. I'm doing this.
All right. This one, same principle, but I want you to solve it without a calculator, right? No calculator. Yeah, just listen without the information. Right, so no calculator, I would like you to evaluate this value, right? Evaluate the value here. Oh yeah, try that quick. And because I know you will like it so much, I'm gonna give you a next one.
Hey, what we doing that? I remember confused, but
All I want to do is give me what the answer is. No calculator. There is a way for you to simplify this. With no calculator. Oh, that means all the bars in the middle. So, you know, same pattern.
what we're going to do? Take the information.
Huh? But a way to find a way to simplify it.
You want to look at it? What's that from 19?
Well, I'll give you it possible.
I really confused everybody.
Yeah, any ideas?
So I don't know.
Huh?
Yeah.
But no calculator.
Yes, sir.
With no calculator, what is what to do? All of them is the same what?
One.
All the same base. And what you have in the middle? Plus sign. So see if something will happen. See if something will happen, right? Online. So you have all to the same base here. You have a plus sign. Right? See what rule you can use. Oh, yeah.
You want to multiply all that?
Huh?
You want to multiply all that?
Something will happen. Just write 2 lines and you'll see what will happen.
And you got this.
Huh? What will happen? Something nice will happen. Kamiko, you all get you? Garage, Kiran. Right, so you have to find a way now to use the rules to simplify it out. All it that means is that I just left out those terms because it followed the pattern. Watch 1 and 2, 2 and 3, 3 and 4. So here is what? 4 and 5, and then so on until you reach here. Right? I just left it out. If you want to write it, go ahead. Right? But I left it out because it's just following the same pattern until you reach here. Okay? I don't want to write 5, 4 and 5, 5 and 6, 6 and 7, and so on, right? I just stop and continue. But it's real simple. Let me be honest, it's about 3 lines long. 3 lines long, no calculator, Marquis, no calculator. Right? Any answers online? Amber, any answers here? Yeah.
You got 1 cent.
Hey, no point in the calculator. Okay, so the answer is 1 cent. How do you get that?
Nah, I don't want to try and see because
And then
we don't see. Now you want I understand, right? I have an idea.
Right, I see one answer online. The answer one over. No, one over. No one over. But the final answer, you mean?
Yeah.
Chara didn't come. Chara didn't come, right? And Kalina. Right, so you'll agree that we're multiplying, and you'll agree that we're multiplying, right? So we multiplying a half by 2/3, by 3/4, by whatever was next, right? That's 4 and 5 and so on, right? All okay with that? Right? And I just skipping out a few and then I go in 8 or 9. Actually, let me write also, I will see it, right? 4 and 5, then 5 on 6, then 6 on 7, then 7 on 8, then 8 on 9, and 10 years later, 9 on 10. See what happening?
Yeah.
This canceling, huh?
Wait, not real too much.
So you're ending up with 1 over 10. So yeah, let's simplify that now. Right? So yeah, let's simplify this. You'll get log 1, sorry, log 10 1 minus log 10 10, which is minus 1. This is 0 minus 1. Yeah, and then fully forward.
Yeah.
Right? So that is your answer. So since I helped you with this one, and I helping you here. Try this one here. Right? And the hints I want to give you, it linked to this. It linked to this rule here. Guys, then I'll give you a hard one, right? Try this one, then I'll give you a hard one.
This is gonna be hard one. Wait, this one, how about the other two?
Yeah, this is what that because it just called pattern. So once you figure out what happened in here, you'll figure out the rest. Right? But you have to use rule 2 to help you, right? Come on, Fame, come on, Fame. Wait. No calculator, put in calculator there. No calculator. No calculator. No, but the question would have award your marks, because the question was said without the calculator. But the hint is you have to use this change of base formula. So I'm gonna ask you, right? What base you would change them to? Yeah, right? Change them all to the base 10 and see what will happen. Right? Change them all to the base 10 and let's see what will happen. What will this be? What will this be? This will be log to the base 10 of all over. Right? Then same thing here, right? What will happen here? Oh yeah, try it out. I do it try quick. Huh? What do you have? So you can do all the videos. We go. Yeah, right now is your chance. Right, so what you all recognize happening? What canceling off? Right, well, not everything. This canceling here. Correct? This canceling here. This will cancel with the term later on, and which one here will cancel?
The last one on top. But then cancel and you.
Right. So this and this remain the same, right? So you're going to get log to the base 10 of 32 all over log to the base 10 of 2. Can you simplify this? 32 is 32, right? Can you simplify that and put it up? 32 is 2 to the base, no?
Yes.
Yeah, and 2 to the 5, right? Right.
So I get the same answer.
Huh?
When I said I get 5, right?
Yeah, the answer is 5.
And when I said I get.
So you didn't leave out, just how much it back. So this is log to the base 10 of 32, which is 2 to the power 5 all over log to the base 10 of 2. Bring the 5 in front, and you'll get log to the base 10 of 2 all over log to the base 10 of 2. This will cancel, and you'll get 5. Okay? But the hint was you have to change them. Because all those will cancel off. The one that I didn't write it, but you have to see it, right? You have to see that all these canceling off, all these smaller terms canceling. So like if I list out until 31, that would have chance. Yours? No, yours good. Yours good. What you remember? Yeah. So if you jump from here to here, you know, I would say use a calculator. If you jump from here,
Look,
to that.
I'm sure that I came with the pizza, right? And then I realized it's still there. And so well, I was doing it. So I would make it right for me. See how far it goes.
you don't want to write all this much. You can write this and this, and then put dot, dot, dot,
Alright.
right? But you have to show them why the last one didn't cancel. All right, nice. Let's go again. Are you okay with this? So sometimes they look like this, sometimes they look like solvent, right?
I don't like this one.
I have to give it. I have to give it. Online, any questions? Online, is send anything else? Cool up, cool up. Right, since you're having fun with that, let me give you a proof. That I real
what?
proof.
I love proof.
Yeah. I don't like this way. Right, Bradley wanted proof for this, so I had to give all that. Right, Bradley wants a proof, so I have to give it up. All these are past papers, and this is 2014 I'm giving you, right? All right, here's what you want to do, right? Watch this here. Right, make sure you read the question properly. The question said, given that this is equal to this, they want you to prove this is this. So basically, you have to show that this is this by using this. You understand what the question say, Ishana? So the question said, given this bit of information, show that this left-hand side is the same as this right-hand side, right? So I don't want you starting here. I want you to start here, right? And see how you're going to use this to help you turn this into this. Okay? See how far you can reach. Please do that, watch it. Try something patient. Let's see how far you will reach, right? Yeah. It's about 5 or 6 lines. It's a little bit longer than a normal proof. Right? But please understand the wording. Give on this, right? So somewhere in your left-hand side, this will come in. Right? You can watch it close, you might see it, right? You might see some cubes in here, you might see it. Copy it down and start with the left-hand side here. Don't watch it, right? Apply along rules and see how far you can reach. Right, come Shivish, come on the board.
Hello, no.
I'm just writing the left hand side. Oh yeah, try that then, quick fit. Right? Anybody want to guys? If we get it, just message QED. QED. Right, so from next week I want to try to 7, right? Well, not try, we go into 7, right? That's okay? Those are the uniform model. Here it up. And only here to 7. I'll give you a break around 7, right? Right, any move here? Tisha? Tisha, what you do with that tree? What's the first thing you can do with that tree? Any other rules could work there? I could put that up. Power, right? So I could write log of a plus b all to the power 3. Right? So what does this mean? This means log of a plus b cube all over 2 cube. Correct? I mean, all I can do now is what? All I can do now is expand that out. Right? Right? Because somehow or the other I have to bring in a cube and b cube and 3a squared b and thing, right? So I'm just doing it here for you to remember how to do it. A plus b cube is a plus b by a plus b by a plus b. I have a shortcut, but I will show you that as yet. So basically, you expand out these two here, you'll get a squared plus 2ab plus b squared. Right? And then multiply this by this, right? So you'll get a cube, a by this, a by this, a by this. Then b by this, b by this, and then b by this. And then when you reach here, group your like terms together, right? Group your like terms together, you'll end up with ab cube. 2 of this plus 1 of this is 3a squared b. 1 of this plus 2 of this is 3ab squared. Right? So if you expand this properly, you're going to get that. Are you okay with that? Yeah? So expand these two, you get this, and then multiply this by this. That's okay? And now we can take that and put it in there. So the expansion for a plus b cube is this. So you will end up with log, open brackets, a cube plus b cube plus 3a squared b plus 3ab squared all over 8. What is this equal to? Shivish, what is equal to? This. Okay, that's it. This whole thing here, up until right there, is equal to 5ab squared. Right? And it should see the rest now, right? You'll get 5ab squared plus 3ab squared. When you add it up, this is 8, right? So you're going to get log 8ab squared all over 8. The 8 will cancel, and you're done. What you want to get? This, right? The 8 will cancel, and you will get log to the base a plus 2 log b. Right? So you're just going to take your time, right? But you reach here, Marquis? If you can reach here, without killing yourself, you can reach here.
No, I reach there. I reach there.
So what you will naturally do if you reach here and you're in an exam?
Yeah. So in our exam, I reached to the bottom there, right? I made the link, I link it or whatever, right? But like now, because I'm not working to that.
All right. So next day we continue with logs and indices, and then we start from. All right. So we'll practice some more of these. I will send a small worksheet to do it good, right? And you will practice some more of this and then start functions next.